Welcome to A Lust for Limits by Anna Gomes and Caroline Evans.
The definition of a limit is L is the limit of f of x as x approaches c if and only if the limit of f of x as x goes to c from the right equals the limit of f of x as x goes to c from the left equals the limit. The positive sign on the right corner of the C means that the limit is being approached from the right side, and the negative sign at the right corner of the C means that the limit is being approached from the left side.
Another important thing to know when you're learning about limits is continuity. So as a function is continuous on a graph f of x, like the line drawn here, at x equals c if the limit of f of x as x approaches c equals f of c. So that's like saying, as you go up to this point, like the limit as x approaches c, so like we'll just say that c is 1, right here, equals 1, so f of c is 1, like when you plug it in for 1, you get 1. And the line, as it goes from the right and the left, is also approaching 1. So it's continuous. Now we're going to do some example problems. So this function is just, we'll just call it f of x. So we want to find the limit of f of x, so the limit of the function, as x approaches 1 from the left. So you're coming from this direction, and this is what you're guarding. This is your c value, so x is approaching 1 from the left. So you're going to follow this line up, and it seems to be approaching 1 from the left side. So the limit of f of x as x approaches 1 from the left is 1. Now we're going to do the limit of f of x as x approaches 1 from the right. So that's from this side that way, from the right. So now we're going to follow this line up to 1, and it's approaching. We're not worried about that that's an open circle or that that's a filled circle. We're just worried about what it's approaching. So it's approaching 3 from the right side. So the limit of f of x as x approaches 1 from the right is 3.
Yeah, that's no big deal.
Now we want to find the limit as x approaches 1 of f of x. So that's not from the right, not from the left. But in order for a limit to exist at a point C, which is 1 in this scenario, the limit from the left and the right have to be the same. So as we just went over, the limit of 1 from the left is 1 and from the right is 3. So the limit as x approaches 1 does not exist because the limit as x approaches 1 from the left does not equal the limit as x approaches 1 from the right. Because these aren't the same, the right value and the left value, then this value cannot have a limit at that point. So now we're going to find the limit as x goes to 4 from the left of f of x. So it's the same function, f of x. So now this is our c value. So x is approaching 4, but right now we're just approaching it from the left side. So we'll start here from the left and follow it all the way down and stop at 4. So the line is approaching value of 1 from the left. So the limit as x goes to 4 from the left of f of x is 1. Now we're going to find it from the right. So we'll start from the right side and follow it all the way to 4. And the line seems to be approaching 1 again. So the limit as x goes to 4 from the right of f of x is 1. So now we want to find the limit as x goes to 4, not from the right to the left, just all together. So as we said before, in order for this to have a limit, the value from the left and the right have to be the same, and in this case they are, which you can basically just see from the graph that it's continuous because there's like no disturbance in the line, and it's just like a smooth line through. So the value for the limit as x approaches 4 is 1. So now we want to know, is f of x continuous at x equals 4? So as we learned by the definition of continuity, in order for f of x to be continuous on x equals 4, the limit from the left and the right have to be the same, as we already know, and the value of 4 at, the value of y, the y value at 4 has to be the same as both of the limits. So that's like
it would have to be f of 4 equals the limit as x approaches 4.
So f of 4, when you just plug it in the graph, so 4, you go up at 1.
So f of 4 equals 1.
And as we just found out, the limit as x approaches 4 is also 1. So yes, the function is continuous at x equals 4.
So here we're back with our example 2. So our example 2, we have another f of x piecewise function. And we're going to start with letter A. So letter A says f of 2, which is a value at 2. So if you go to 2 on your x-axis, you want to find what your value is, which is 1. Most people think f of 2 would be 4. That's wrong. That is your limit. You would just find your value at 2, which equals 1. For B, your limit of f of x is x equals 2 from the right. So this is where you start on your right side, and you're going to follow your function all the way to where it goes to 2. So at 2, your limit from the right approaches 4. And now for C, you're going to find the limit of as x goes to 2 from the left of f of x, which is your equation. So you're going to go from the left-hand side, and you're going to follow 2 as well. So when you follow your 2 from the left, you're going to approach your value of 2, which equals 4. Value of 2 from the left, you're approaching 4. From the right, you're approaching 4. So your limit of f of x as x equals 2 equals 4. Example E. We're going to find the limit as your f of x approaches 0 from the right. So you're going to follow your equation from the right-hand side, and you're going to follow it all the way to 0. So the limit as x approaches 0 from the right equals 0. Now you're going to find the limit as x approaches 0 from the left. You follow your equation from the left, it goes down here to -3. So with our definition of limits, the limit from the right is 0, the limit from the left is -3. So the limit as x goes to 0 of f of x does not exist. Example letter H is finding the limit as f of x approaches infinity. So as we follow our graph, x approaches infinity. As x approaches infinity, gets bigger and bigger and bigger. Your f of x is approaching 0. As x approaches negative infinity, so as your f of x is getting smaller and smaller and smaller, it's approaching the asymptote of -1. So the limit approaches 0 as f of x approaches infinity, and approaches -1 as f of x approaches negative infinity. Besides finding limits graphically, you can also find them algebraically. Take letter A, for example. Limit as x approaches 5 of x squared. So all you do, since it's a simple equation, is you just plug 5 in, and your limit as x approaches 5 of x squared equals 25. Now for B, it's not as simple. Your limit as x approaches 1 from the left of 1 over x minus 1. So for this kind of equation, we're advised to set up an x and y chart where you plug in numbers to see what the number is approaching, right? Limits are what the graph or the equation at that point is approaching. So if you plug in 0.9, you get -10, 0.99, -100. You're getting closer and closer and closer to 1 from the left side, basically is what we're doing. And it's approaching -1000. So as the number gets closer and closer and closer to 1, it approaches a higher number to the negatives. So you're approaching negative infinity. As the limit as x goes to 1 from the left-hand side of 1 over x minus 1 approaches negative infinity. Because as you get closer and closer and closer to 1 from both sides, or from the left, excuse me, you get farther and farther away as you approach negative infinity. So our next example, example C, is the limit as x approaches 1 of x squared plus 2x minus 3 all over x squared minus 1. So for these kind of problems, you have to break it down and to find how your limit approaches your equation. So basically, right on the top, you know that you can break this down, and you know you can break the bottom down. So you know you can break the bottom down to x plus 1, x minus 1. And your top breaks down to x minus 1 times x plus 3. So if you multiply these times each other, you get this equation. And if you multiply these times each other, you get x squared minus 1. So when you get to this, you know that you can cancel out these. So that leaves you with the limit as x approaches 1 of x plus 3 over x plus 1. So at this point, you can just plug in your limit, because your limit as x approaches 1 of this equation. So you get 4 over 2, or 2. So the limit x approaches 1 equals 2 of your equation. This is all for C. So basically, just to recap, you're trying to find the limit as x approaches 1 of this equation. But if you plug this in, it will not get you the right answer, because you need to break it down first and pull out those things that are not necessary. So if you factor this out into these two, you can cancel out this, and you get x plus 3 over x plus 1, which gives you 2. So the limit as x approaches 1 of this whole equation equals 2. Now, our second one, we're going to deal with a different property. The limit as x approaches 3 of the square root of x plus 1 over x squared minus 1. So what this basically means is you're going to have the limit as x approaches 3 of the square root of x plus 1 over the limit as x approaches 3 of x squared plus 1. So for this, now we would just plug this in. As your limit as your x approaches 3. So as x approaches 3, just for the top, you're going to get 3 plus 1, the square root, which is 4. The square root of 4 is 2. So on the bottom, your square of 3 would be 9 plus 1 would be 10. So you end up with 2/10 or 1/5. So basically, you just have to take your limit as your top and your bottom, solve it, and then combine to get your answer. What did I do wrong? Shoot. Hey, friends. So, anyway, just to recap, I wrote this wrong. This should be x squared minus 1. So you should get 8 on the bottom. And you should get 1/4 as your answer. You have to make sure you don't make little mistakes like that, or it could ruin your entire process.